Hi, welcome to the video on double revolving theory of single phase induction motor. So before discussing about double revolving theory of this single phase induction motor, let us understand why we have to study this and why is it so important. We know that single phase induction motor are mainly used in lighting purpose like in shops, office, houses, etc. And single phase AC supply is commonly used in all these areas. So instead of DC motors, where which works on single phase AC, are very popular in use. So these AC motors, working on AC is called as induction motor. The numerous applications in domestic where we can come across is in fans, hair dryers, blowers, food processor, mixers. So the working principle and applications of various types of single phase induction motors are also discussed in this, concept of induction motor. So before that, why we need this double field revolving theory. So to work with that, uh, so we know that for any motor, there must be having two fluxes which interact with each other to produce a torque. So in DC motor, field winding will produce the main flux and DC supply is given to armature, which will have armature flux. These two flux will interact to produce the torque. But in single phase induction motor, single phase AC supply is given to the stator winding. It carries an alternating current which produces the flux which is also alternating. So this flux is called main flux. So since the main flux is alternating, we don't have a rotating magnetic field. So this flux will link the rotor conductors, due to transformer action, an EMF gets induced in the rotor. This EMF induce will produce a current in the rotor which produces a flux, that is the second flux which is required to interact with the main flux to produce a torque. But as against in the DC motor, separate supply we give it to armature to produce armature flux. But the only difference is between DC and induction motor is that there should be a phase difference between two fluxes here. So since if the phase difference is absent, therefore DC motors are self-starting, while single phase motors are not self-starting. So let us see why single phase induction motor are not self-starting using this theory called double revolving theory. So looking at this, according to the double revolving field theory, let us consider two components here of the stator flux. This stator flux is resolved into two components, each having the magnitude. One component is phi f and phi b. Phi f having a magnitude of phi m 1m by 2, and phi b is also having a component phi 1m by 2, where phi m and phi 1m is the maximum flux produced in the stator, where phi f is rotating in the anti-clockwise and phi b is rotating in the clockwise. Since the magnitudes are same, the resultant flux becomes zero here. So the resultant of these two components at any instant, okay, will give the maximum flux. So this figure one will show that components, as I discussed, phi f and phi b, which is result of the stator flux and of the magnitude phi 1 m by 2, and the algebraic sum of this at this position becomes 0. So when it moves again, the magnitude of these two is same and resultant becomes 0. So any point the resultant flux becomes 0. So if you relate this forward flux with the rotor flux, now a forward flux with the rotor flux produces a forward torque, and the phi b links with the rotor flux produces a backward torque. In that case, the resultant flux produced, if you can observe here, look at this dotted line indicates the forward flux produced by the stator interacting with the rotor flux, and the torque produced in the backward from the stator field interacting with the armature flux will produce a backward torque. So the resultant of these two, if you observe, the resultant of these two will give you the the speed is zero and the torque also zero at start. In that case, after starting, you can see the resultant of these two will produce a resultant torque, which is as per a three-phase induction motor. If you look at, if you lift this from zero to somewhere here, the characteristics goes as per the three-phase induction. There will be a starting torque. So in order to move this resultant torque from zero to certain value, we need to make some modifications in the stator flux, and this resultant of torque, backward and forward torque, is mainly because of the stator flux linking with the rotor flux, the stator flux which is resolved, the backward and the forward flux, so which is interacting with the armature flux results in the forward torque and the backward torque. So resultant is zero. So to overcome this disadvantage, so at start these two torques are in equal and opposite direction, it will not rotate anymore. In that case, we need to give an initial rotation for the rotor to move, so that torque is being produced there. So in general or in practice, it is not possible to give the initial torque to the rotor externally, hence some modifications to be made at the time of construction of single phase induction motor to make them self-starting. So as the stator flux is resolved into 2 and resultant is getting 0, we need to add an external flux, add an external flux in the stator field, where it interacts with the rotor flux to produce a torque. So in practice, there are some arrangement made to give an additional flux at the stator, so that additional flux given to the stator, we have different methods to start the induction motor, that is using split phase induction motor and capacitor start induction motor, capacitor start capacitor run induction motor, and shaded pole induction motor. So these are the types of methods we can use to produce a stator magnetic field as rotating rather than a alternating flux, so that it interacts with the rotor flux to produce a torque. So initial torque cannot be zero. To overcome this, we need to make certain adjustments. So according to double revolving field theory, it explains that the torque produced in at the start will be equal to zero, because the stator flux, which is alternating in nature and which is resolved into two components, one is clockwise and anti-clockwise, resultant flux in the stator becomes zero. So we need to add an additional flux in the stator, which will link with the rotor to produce a initial torque. Thank you for watching.